Okay, I'm going to show you some really useful routines on your calculator. You'll find these very, very useful in all of your math courses for the rest of high school. So this lesson is really kind of important. You'll learn to use more and more parts of this calculator over the different courses. So what we're going to be looking at today is how to graph and find points on the graph. All right, so the first thing you want to do is press on, like this. Press the on button. Press the number 1 button. And then scroll across to the right and say, no, I don't want to save. And then always click add a calculator. You always want to start with a calculator page, even if we're not using it much. Okay, you should be at that point now. So what we want to do is we're going to add a new page here. And we do that by pressing this control button there. And then we click where it says document. You can notice above it in red, it says add page. It pulls this one up again. We can press the number 2 button, and that will add a graph page for us. We need to then type in the function that we've got. We're asked to graph this function here. This function here, we're asked to graph this one. So it says f1 of x is equal to, and here at this point we type this in. So we go x squared plus 4x plus 4. Type in the function that we see there. How are you so far behind on these instructions? How are you so far behind? This isn't a job. You guys don't have a calculator to show? Press enter when you're done. Press enter, and it'll draw your graph for you. So if we want to find a point on the graph, so we need to use the graphing calculator to find the value of the function when x equals 0. We can see that is going to be this point here on the graph. We can see that, but we can actually get it to calculate the exact value first. We press menu. And then we choose 3, 1. Oh, sorry, no, we don't want to do that. We've done that. We want to press 5, 1. No, we don't. Yes, we do. Sorry. We're here on this bit. We want to press menu 5, 1. Nothing seems to be happening, but if you press 0 here on the keyboard, you'll see x equals 0 up here. Then you press enter twice, and it will record a point on the graph for us. Okay? So this basically is one of the most useful routines for us. It'll allow us to calculate the point on a graph. That's it. That's the routine. So let's use that routine a little bit now.
So,
yeah.
What's the point of making a second page?
As we progress a little bit more, we might do more things. So we often like to come back to the calculator page to do calculations with the number. For instance, I can calculate what we just did then by doing this as well. I always like to have a calculator page. You often make calculations with the things that you calculate on the other page. Just my routine. Okay, let's have a go at a couple of questions like that one. So we need to graph each of these functions and find the y-intercept when x equals 0. So I'm going to do the first one for you and show you what the routine is one more time. If you want to watch me through on this one, and then I'm going to ask you to do the other 3. So what we do is we want to graph this new graph. So in order to graph a new graph, we can press menu 3, 1, and it pulls up the graph entry like this. We can scroll up and down between the different ones. So that's that one drawn there. If I want to delete that one like this, I can delete it. It'll disappear. Another way, instead of pressing menu 3, 1 to get to here, is we can press the tab button and it pops it open as a shortcut for that. So we can press x squared plus 3, enter. And then we need to find the y-intercept when x is equal to 0. And we do that by pressing menu 5, 1. We type 0, we press enter twice, and we get 0, 3. So the y-intercept here on this one is 3. Okay, I'm just going to pause the video a minute, have a go at the next 3 for yourselves. Okay, so what answers did we get here? So for the second one, we found that the y-intercept is 0. Here on this one, we're putting x equal to 0. What did we get for the y value? Y equals minus 8. On D, x equals 0, y equals 12. Right. How can we see what the y-intercept value is by looking at the function? Look at the for this investigation, look at the numbers that we got and try and see if you can see those numbers here.
They're all 0. Well, the x value is 0.
Well, that's an easy one. What about the y values?
Well, they're not 0.
They're not 0. But can we see them in the function? Let me give people a minute and I'll ask you. Can we see them in the function? Okay, Mary.
There's a one step without the x or x squared.
Yeah. So what she's saying is this number here is this number there. And she says this is the number without an x in it. So what she's referring to is standard form. Standard form, if we rearrange these ones into standard form, we would get y equals ax squared plus bx plus c. And it's this c value, which is the y-intercept constant, always, always. So in this case, we've got a plus 0. We don't have one of those. Here we have a negative symbol. And even if it's not written in standard form, it's still this number here. So it's whatever number is on its own in the function. Okay, now we're going to do these ones. Let me do the first one for you. So we're going to do the same type of thing again, practicing using our calculator. So we need to enter in this first one. We start by pressing tab, we scroll up, we delete what was there, like this. Press tab, and then we need a bracket x minus, use the subtraction here inside the bracket, close the bracket square, press enter. Then we press menu 5, 1, and then type 0, and press enter twice. So this one is going to have, y equals 4. Okay, I'll pause the video a minute, have a go at the next 3 for yourselves. A little bit quicker this time, hopefully. Okay, so what we see here, if we find the y-intercept constant in each case, we can see it by expanding the brackets and doing the algebraic simplifications, and we can find the y-intercept constant. Here's our next step. Okay, the first one, what's the y-intercept constant going to be here on this one? Negative 1? Let's have a look at the expansion. So when you're expanding a bracket like this one, notice that you have a coefficient outside the bracket. My recommendation for this type of a question, which we'll have on the semester exam, is to put a little square bracket there, blocking off the coefficient. Put a little square bracket like that. Notice here on this third one how I don't include the 3. So I put a little square bracket just around the bit that I'm going to expand. So I will leave that square bracket there, like this. I will leave that square bracket there, and then I'll expand what's inside the bracket. So this one is going to be x squared minus 2x plus 1. Then open up the red bracket I've added. It's going to change the signs on everything. It's going to give us minus x squared plus 2x minus 1, which is why this negative 1 here, this one here becomes negative. It's caused by that minus sign. Let me do another couple of these ones because we do need to practice this. So here we have a minus. Yeah, so if you notice how fast I'm going on the expanding, I'm using the rule that we should have practiced. So we have some rules that you need to memorize. So if you have x plus a squared, this is going to be x squared plus 2ax plus a squared. I'm using these rules that we looked at. X minus a is going to be x squared minus 2ax plus a squared. And then the conjugate rule, x plus a, x minus a, gives us x squared minus a squared. So these are the three special cases we looked at. And then we practiced on the IXL. There's an IXL practicing these ones. Let me show you which IXL it is that practices these ones. So here in IXL, in the learning, really useful to do these if you see how fast I'm doing it, really useful to practice these rules. You can get there with FOIL, but it's so much slower. Hopefully you can notice that. So down at the bottom. Sorry, just trying to find here it is. W for polynomials, and then number 9, special cases. So this IXL here is all about the routines that we've done. As you've seen, we've done it. That's why it's got the little star next to it. And it's about practicing these. So watch the video, learn with examples, make sure you know this one.
For the example, we have to expand.
Yes. If the question will tell you, I'll say expand and simplify, or just simplify, and then you have. So I'm using that. So we've got x, so we get x squared. A is 2, so it's 2 times 2, which is 4, so we get plus 4x, and then we get 2 squared, so plus 4. You put the red bracket back in. Now we expand using the red bracket. We get minus 2x squared, so minus 2 times x squared, minus 2 times plus 4 gives minus 8x. Minus 2 times 4 gives minus 8. So what is the y-intercept constant in the second one? Minus 8. What's the y-intercept constant in the third one in C? Let's see some hands. Let's see some more hands I've not seen before. Okay, what did you get to see?
Or you expand the brackets, x plus.
No, what did you get as a y-intercept constant, not the whole expansion? Okay. Amir? You got 0, comma 2. Let's check if he's correct. So we need the square bracket like this. We do the expansion. So using the rule, remember, which one have we got? We got plus, yeah. Using the rule, it's going to be x squared plus 2 times a times x times a squared. So x squared, 2 times a is 2, and then a squared is plus 1. Expanding the bracket, we get 5x squared plus 10x plus 5 minus 3, which gives us 5x squared plus 10x plus 2. He's correct. Okay, let's move on from this a little bit now. So we're going to practice, we've got 3 cells today. We're going to practice each one, showing you how you can use the calculator to help you a little bit. Let me start a fresh video on this one.